homework 3 to 23 odd. Work on the study guide, probably weekly homework question on Tuesday. I'm working on a new survey. If I get to it, it'll be online. It's not due yet because I haven't even posted it yet. But if you're bored and you look online and you see a new survey there, then do it, okay? And next week when I get it all together, I will bug you and tell you when it's due, okay? We are working towards the test on Friday. That means next Thursday, I'm taking your questions from the study guide. You're first coming back on Tuesday and learning the last lesson. And so Tuesday, Wednesday is the last lesson. Like Tuesday, I finish it. Wednesday, I put all the pieces together. So do you see how quick the week's going to go? So please, please work on some of the study guides so that when you have everything else and you're really busy, you don't have the time to put into my class. I need you to have time to put into my class. Today, we're going to be rewriting radicals by extracting roots. Didn't we do that already? Like square root of 8 was 2 root 2. We are going to be adding, subtracting, multiplying, and dividing. And we're going to go back and forth between radicals and rational exponents. What is a rational exponent again? Fraction power. Good. Okay, here we go. So both of these girls did a good job. Both Ariana and Heidi did fine on this. Can you see, and I put this up here because I wanted you to see that now that we're in Algebra 2, sometimes there's multiple approaches and they still get you the same fine final answer. Okay, so Ariana opted to put the values inside the radical together. She multiplied them together first and then broke them apart. Heidi said, oh, I see 18 is a 9 times 2. So she broke it apart as she went. It is totally up to you what approach you take. So I'm just going to talk Ariana. Once she said 18 times 3 was 54, she said, when I see 54, I see the perfect square 9 times its other factor 6. You know the square root of 9 is 3. You do not know the square root of 6. Do you know the square root of a to the 4? Yes, a squared. Voila, she was done. Question? Okay, now, we're going to work on one of these in a sec. What did Jackie do that made her wrong? It's thumbs down. What did Jackie do? Anybody tell? Okay, so one of the bad things is she left a radical in the denominator, but she even did something worse than that. Go ahead. Wait, okay. Okay, so she did, something's wrong with the BC, and she divided it out, but it's because, what's wrong about it? What do you notice? Yeah, one is a square root and one's a cube root. In order to put these guys together, they have to be the same root, okay? So as soon as they weren't like indexes, you can't do what she did, okay? So what we're going to have to do is convert it over to fraction powers to use some other rules. So step 1, she treated it like they were both the same kind of radical, and then she blew the problem already, okay? So now, Maxine started right, she just stopped where she should have kept going. Robert works through the whole problem, and you can actually approach this 2 different ways. So what Robert did was, first thing he said, I see that my radicals are different, so I can't just reduce. He can either convert them over to fraction powers first, and then after he does that, he can do some simplifying, or he can get rid of the radical down below first, which is what he did on this one, and then simplify it after. So I'm going to do this way, and then I'll show you one in the other order afterwards, okay? So let me talk about Robert. This is in your textbook so that you can just stare at me up here. Do you see in this denominator a cube root of b squared c squared? Does everybody see that? So the cube root, that index 3, is saying we need 3 of the b's and 3 of the c's. Right now, how many of each do we have? Just 2? How many more do you need if you have 2 to make 3? 1 more, okay? So we need 1 more b and we need 1 more c. Because remember, like base, you add powers. So do you see how we're going to multiply by a bc? Anybody not see that? Okay, so b to the 2 times b to the 1 is b to the 3, good. And c to the 2 times c to the 1 is the c to the 3. Do you know the cube root of b cubed c cubed? bc. Okay, So you see how they cleaned up the denominator first? That was their goal, was to get a nice clean BC. That way they don't have to worry about that anymore. Now, up on top, they have this. Do you see how they're not like indexes? So in order to put these together, we need to convert it to fraction powers. So let's do it. Square root is like the half power, and cube root is like the 1/3 power. Question for me so far? Okay. Like base. Do you see BCs? They're both like. You could say the whole alphabet in parentheses by multiplication. It's a like base. Like base multiplication, the rule from yesterday, the first one. Somebody needs to wake up. Like base multiplication, what do I do with my exponents? You know this. Like base multiplication. You add them, exactly. Okay, so we're going to add the exponents. Uh-oh, you have to add fractions. I want to add 1/2 plus 1/3, better known as 3/6 plus 2/6. What do you get? 5/6, okay? So we have 5 BC to the 5/6 power over good old BC. And then they just finished it up by rewriting it in radical form, which most of the time the directions will tell you to do. If they don't tell you to do it, then you don't have to. Okay? So how do I know that this ended up being the index? On the bottom. It's the denominator of the exponent will always be the index. And then you would be done. Okay, so that was a long problem, but there wasn't any skill you don't know. It's just that you had a long process. You had to take care of rationalizing a denominator, and then you had unlike index numbers, so you had to combine like terms, and then after that you had to clean it up and take it back to a radical again. Okay, let's do a couple of these real quick. What can you do on the outside? Tell me. I'm going to start calling names. Outside, what do you see there? 2 times 5 is plain old normal 10. Everybody good there? Okay. Now, do you see a square root of x times square root of x times square root of x? What is that like? Square root of x cubed? Is this done? Is it finished? Is it simplified? No. Isn't it taken for granted that there's a little 2 there? How many times does 2 go into 3? Once. Good. And is there anything left over? Okay, now, I didn't have to put bars on this one. I should have, but I didn't have to because in the beginning, they're giving me that restriction. They're telling me x is positive. If you put bars, that would be great. But they're already telling you that, so you didn't have to worry about it. Question? Okay. Next one is really, really quick. Anybody have an answer? You think you know? You look like you're iffy. 2 cube root of k squared. Done. That's it. Question? Okay. Next one. You can't combine the values inside the radical because one of them is an h and one's an h cubed. So in order to add and subtract, the index has to be the same as well as the exponent, like the value inside, which is your radicand, that has to be the same as well. So that means we're going to do distributive. So let's distribute. 7 times 3. Square root of h times square root of h simplified. H, good. Plus 7 times 4. Okay, in your head, square root of h, listen to my words, some of you are zoning out on me, square root of h times square root of h cubed gives you square root of h to the what, which equals what? Perfect. Gives you square root of h to the 4, which gives you h squared. And we're done, and they're telling us h has got to be positive, so I didn't have to worry about the absolute value bars. Question? As is, can I multiply those guys together? What do you think? No. Do you know how come? Cube root, square root. The index is not the same. Okay, so we need to convert them over to fraction powers. So when I see the first one, I see a to the 1/2. Do you agree? And in my second one, I see a to the 1/3. Very good. Like base, keep the base, add the powers. 1/2 plus 1/3 again. 5/6. Okay. So we have a to the 5/6. And if they tell us to rewrite it in radical form, so here's a radical, there's the a, where do I put the 6? Awesome. In the little thing, which is the index, and keep the 5 with it. Are we good? Okay, and moving on. Okay, there's already an n on the outside, so what I would recommend on this one, since they're both cube roots, is let's multiply it together. So I see a cube root of 4 times 2 makes 8, n to the 1 times n to the 2 makes n to the 3. Do you see what you're going to do next? What is the cube root of 8? 2. And what is the cube root of n cubed? N? But there's already an n outside. Perfect. This last one I could do in my head. I bet a couple of you can also. Go. See what the answer is. Anybody get an answer? 2x. Yeah, that's it. So that's some of you, I want you to be there, that you could go, oh yeah, I see it. The x to the 4 over the x to the 2 is an x squared. I know the square root of 4 is 2. I know the square root of x squared is x. And bars, because they didn't tell me x was positive, and I'm done. Question. I can do these till I'm blue in the face, and when I cough, sometimes I feel like I'm going to be blue in the face. But this is all about practice, guys. I can't practice it for you. Each problem is a little different than the other one, and that's why we give you ones to practice as well. But you really need to go home and make sure you can own this so that you can finish it up. And then next week, we'll do the last step, which is the solving. Okay, so what I want to do right now is break you up. If you are this whole group right here, this 9, I'm going to have you do the first one, A, and the rest of you guys over here, you're going to do C. Go. And help each other. Definitely, if I was doing it, I would write stuff down. I didn't do these visually. Guys help each other. No chattering. Are you like in agreement with each other to do it separate first and compare it? Anybody in group A think they have an answer? Group A, that's this group of 9. Anybody? Did you guys get anything? Okay, close. 2 over 5 times, go, it's the root that's wrong, the index. Pardon me? The 6th root of A. 2/5 times the 6th root of a. Let's do that one first. That's good. You're the first group, though, where you've come up with the final. The other people have missed something about it along the way. So I could rationalize it first, or I could go right to fraction power. I would do fraction power first because on this one it ends up being quicker. So this is what I saw. Like base, I'm going to subtract the powers. What is 1/2 take away 1/3? That means 3/6 take away 2/6. 1/6, very good. Still with me? And I want to rewrite it in radical form because the direction said so. How do you write 1/6 power in radical form? 6th root. So there is your 2/5 6th root of a. Like base division, with the a's, subtract the powers. So you did 1/2 minus 1/3, or 3/6 minus 2/6. Anybody not good at that? Okay, so sometimes switching it over to fraction power right away is quicker. Could I have rationalized it first? Absolutely, it was just more steps. Okay, next one. Let me see what the answer was. Anybody, there's a bunch of you, 3, 6, 9, 12 of you. Did anybody out of the 12 of you get a final answer that starts with a -2? Uh-oh, so that means you need me, huh? Okay, so. Okay. Okay, you're not done. Yeah. Okay. So let's see what we can do. They're both square roots, so this is good. We can put it together inside one radical. Before I do this, I see that there's a square root of 4 hanging there. You don't have to do this right away, but I do. Do you know the square root of 4 is 2? So let's just pull it out because we know it. So we have a -5, and you know the square root of 4 is 2. So I'm just going to write -10. Okay? And now at least I've taken care of the 4. I'm going to put everything else together inside, keep doing that, inside one radical. And we have j to the 2, k to the 5, the 75, j to the 1, and k to the 2. We'll deal with the 75 in a sec. Right now, let's deal with the j and the k. Like base division, what do you do with your exponents? Subtract, right? Remember, that was the second rule that we had up there yesterday. So if we're going to subtract, then you have a j to the 2 over a j to the 1, which gives you j to the what where? J to the 1, top or bottom? Top. It matters. How I know where to put it is, would you agree 2 is bigger than the 1? That's how I know it landed on the top. So I had this -10 outside, and so far you guys told me j or j to the 1. Now let's do the k. K to the 5 over k to the 2. Like base, subtract the powers. 5 take away 2 is 3, and it's going to go again on the top. Now, I'm going to take the liberty to rewrite 75 as a 25 times 3. Would you agree with that? Okay, let's keep going. What is the square root of 25? So I can simplify that. 5, okay? So I have a 5 there, and then I had a -10 here. So that would be -10 over 5, which is what? -2. Okay, so I have -2 so far with that. Now, with the k, can I pull anything out? What? So there's, taken for granted, there's a little 2 there. So 2 goes into 3 once, with 1 still left inside. Okay, what do we still have left down below? The square root of 3, can we leave it there? No. So what do you think we have to do? Rationalize. So that means we need to multiply by square root of 3. And whatever you do to the bottom, you do to the top. Okay, so we already used this up, so I'm just going to check them off so we don't reuse it. What is square root of 3 times square root of 3? Square root of 9, which is 3. Okay, so that's good. And then this guy right here, you're just going to shove inside here. I'm going to put it at the end, but normally I would put it in front. So that would be my final answer. Negative 2/3 k, square root of 3jk. Question. A little bit more work, just because you had to rationalize the denominator there. But nothing about it should have been hard. Just you had to know how to get to the end. Question for me. Not going to chat long on this, but I wanted you to see this. Would you agree that you wouldn't even think twice? 3 root x plus 1 root x is 4 root x, right? So when you have the fraction power like this, 3x to the half plus 1x to the half is 4x to the half. It's still those same rules. Now, tell me what Ron did wrong. What did Ron do wrong? He added them, but the indexes weren't the same, and we're not allowed. Okay, awesome. Sheila. Radical. Yeah, she put them, it says plus. They're not even like values inside the radical. So the radican's not the same, so you can't add them. She multiplied them and said she had 2 of them, so she just created new math. She had no clue what she was doing. Okay. Question on this. Okay, I am going to skip over to this so that I have plenty of time. Okay, so let's look up here. This is a question from the homework. I know it's even. You guys are doing odds, but it's what goes with it. Now, I typed in a hint. You won't see hints typed in on the skills practice. But I consider this a really easy problem, just so that you know easy, medium, hard. I would consider this really easy. Do you see that you could simplify? Could you reduce first? Because your indexes are the same? So if I want to reduce first, somebody tell me what to write in my next step. Square root of r squared t. Awesome. Okay. Anything else I can do? Square root of r squared is r. And then since it didn't say that my r value was greater than or equal to 0, I would put the bar around it because my index was even. Anybody not good? Okay, this next one, I'm going to work through with you. You have a choice, but do you notice that to start off with, you do not have like indexes? So you can go the route of either A, first taking it to rational exponents and then simplifying it, or you can try and simplify the denominator first, and then after you do that, put together whatever we need to put together. And I'm going to go that route instead of their route. Okay, so do you see this as a cube root? So sorry. Cube root of x. So I have 1 of them right now. How many more of them do I need to make 3 of them? 2 more? Okay. So I'm going to multiply by the cube root of x squared, and whatever I do to the bottom, I have to do to the top. And the reason why I'm doing that is I want to make my denominator nice and clean first, and that way everything I do is going to be up on top. Okay. So I see here a negative 7, and I have a 4th root of x. And I have a cube root of x squared. And down below, I'm now going to have a normal 5 and a plain old x. Would you agree? Everybody agree with that? Okay, so the denominator is rationalized. That part's done. And again, you can do it first or at the end. Everything else I need to do on this one now is up top. I want to multiply the 4th root of x with the cube root of x squared. But in order to do that, I need to switch them over to those rational exponents, the fraction powers. So I see this. I see this as x to the 1/4, and I see this as x to the 2/3. Does everybody agree? Okay. Like base multiplication, what do you do with your exponents? Add. Okay. So this means common denominators, right? Would you agree 1/4 is like 3/12? What is 2/3 like? 8/12, okay? So if you put those guys together, you get 11/12. So I have -7 over 5x, and I have an x to the 11/12. And that would be fine unless they say go back and write it in radical form. So in radical form, I see this. Tell me which one is the index. Which one? 12. Good. And keep the 11 there. Question? Anybody? So they worked it a different route. I just thought it was a little bit messier, so I left it up there so you could see what they did, which was fine. And then I showed you my way, which actually took less steps. Okay? But again, it's always up to you. Here comes another one. I like this one. I usually put something like this on a test. Do you notice that this one is a cube root? Look where I'm pointing. So this one is cube root of r to the 4, s to the 3. The next one is a square root, and the next one is a cube root. So are you allowed to put all 3 of them together? No, but you can put 2 of them together. So that's all you're going to do is put together this one with this one. So you know 9 of them, take away 3 of them, gives you 6 of them. Them being the cube root of r to the 4s cubed. And then I would do some simplifying. They left off. So let me rewrite this. I've got the 6. Does 3 go into 4? Yes? How many times? Once. Okay. With an r left inside, and 3 goes into itself once. Minus 2. Does 2 go into 4? Twice. And 2 goes into 3 once, with 1 left inside. That would have been cleaner. Okay. Simplify it down. And on a test, you're going to want to simplify everything. Question? I would simplify as much as possible. First, be careful with unlike index values, is my note to you. Okay, so I can't put the first and the second on the top together. However, do you see the first value in the numerator and the value in the denominator? I am allowed to simplify those. Okay, so that's what I would do first. So let's check this one out. If I group this together first, and you can pull stuff out as you go, you can simplify it. Do you see that square root of 9 in the denominator? What is your square root of 9? 3. So when I see this already, I see 3, and then I see a 3. Are you with me so far? Okay. Now, I would group these together inside one radical. So now, when I go to deal with my x's, like base division, subtract your powers. 7 take away 3 is 4. Good. Okay, now be careful with the y's. Where is y bigger? On the bottom. That means that's where y is going to land for now. So like base division, you still subtract your powers. You don't want a negative exponent. So if I did 4 minus 10, it would put a -6 up here, and I'd have to move it. So let's keep it down below. 10 take away 4 is 6. And we'll simplify it in a sec. Everybody good with this part so far? Okay, I'm going to break this down a little bit more, and then I'll put it with the last part. Do you know anything about the square root of x to the 4? So we have 3x squared. And do you know anything about the square root of y to the 6? Y to the 3? And what about these 3's? What could you do? Cancel? Good. I would do that as well. Okay. So I've done what I blocked in there. Now, let's do the last part. You have a cube root of -8. What is the cube root of -8? -2. Okay, so let's put that down here. -2. And you have the cube root of x to the 6. X squared. Good. And you have the cube root of y to the 4. A y comes out, and there's a y left inside the radical. And now I'm up to just consolidating. Everything else is already done for me, so let's see what we have. Ooh, I can cancel something too. Okay, so I see a negative 2. X to the 2 is x to the 4. The y's. Y to the what, where? There's a y to the 3 down below and a y to the 1 on the top. Y squared on the bottom, perfect. And then just rewrite your cube root of y. Question for me. Anybody? Okay, and then this number 24. In order to put them together, you first might want to simplify this. This is like the most in-depth one of all of them, which would be like your last kind of problem. So do you notice that this first group right here, I probably could do some simplifying of it first. And the second group right here, because they're both fifth roots, I could do some simplifying of it as well. But in order to do that, they both have the same index, but their bases are different. So that's what I had to worry about. So I would rewrite this with a fraction power, which is what they did here, 3 to the 1/4 and a to the 7/4. Rewrite this as a fraction power, a to the 3/4. And the reason they did that was so that you could start simplifying the a's. So let me just point this out, and then I'll be done with you guys. Look at the a part. Do you see a like base a? Subtract your powers. 7/4 minus 3/4 would give you a 4/4. What is 4 over 4? That's how they got this plain old nice little a to the 1 there. Okay? And then they did some simplifying here. They rewrote the 2. They said like base with the 3, subtract the powers. This is a power 1. 1 take away 1/4 is 3/4. And then they did similar on the other part, okay, to put it together. That's the hardest one. It had all the meat in it. So please, this weekend, nice long weekend, get some sleep, get better if you're sick. Work on my study guide besides the homework, okay? Remember, a week from now, you'll be finishing up your first test of the new semester, okay?